Let's do the third example problem. This is the example problem starting on page 131 and then goes over to page 132. And I'm going to use the procedure to solve this problem. And hey, if you've already done it and you want to just work on other stuff, go ahead. Okay, just don't interrupt here. But here's the problem. So the first thing is you read the problem. It says you push a 25-kilogram wooden box across a wooden floor at a constant speed of 1 meter per second. How much force do you need to exert on the box? Okay, so the first part of the procedure is to write down what's given around a picture. So here we have, and this is wood, and here we have a wooden box, and we're applying a force to it like that. That's what we're trying to find here, is this applied force. We know that this is made out of wood, and we know that we're moving, the velocity is 1 meter per second, and that's a constant velocity. And what we're trying to find is the applied force. Okay, so this is how you would start. We've just done step one of the procedure for problems involving force and motion. So now let's solve it. The second step of the procedure is to draw a free body diagram of the object of interest, in this case, the crate. So let's draw a free body diagram of the crate. Now we've got gravity. So the mass of the crate times g. Oh, they gave us the mass of the crate. I forgot to write that down. It's 25 kilograms. So m equals 25 kilograms. And then we've got a normal force acting on the crate. And then we've got an applied force. But we also have now a force of friction. And this is a new force to a free body diagram. So let's just put it on there. Force of friction. And it's kinetic friction, but I'll just leave it like force of friction. Okay, we just did step 2. Now, this step is probably the most important step, because if you can correctly identify all the outside forces acting on the object, then the other stuff is just like following a recipe. But this requires you to really think about what's going on, what's happening to this crate, what forces are acting on it. Step 3, well, we'll just make this the x direction and this the y direction as usual. Again, this becomes more important in Unit 5. Then we do step 4. We sum the forces in the x direction. That's going to be equal to ma in the x direction. We will also sum the forces in the y direction and set that equal to ma in the y direction. Now these are just kind of instructions. This is what I'm going to do. Don't think of this as an equation so much as think of this as, okay, here are your instructions. Add up all the forces in the x direction, set that equal to the mass times the acceleration in the x direction. Okay, now we're going to execute those instructions. Look at your free body diagram. What forces are acting in the x direction? Well, this applied force minus the force of friction equals ma. But what is the acceleration of our crate? Well, it told us that the velocity is 1 meter per second and that that's constant. So the acceleration is 0. Now this tells me that the applied force is just going to be equal to my friction force. And this makes a lot of sense. It's just like the lab we did. But what is the force of friction equal to? Well, we just said that the force of friction, in the lab, we developed the idea that the force of friction is equal to mu times the normal force. Well, so now we have to say, well, what is mu and what is the normal force? That's what I need to get my applied force. Well, let's get mu first. Mu, well, it said that it was wood rubbing across wood, and in your book there is table 6.3, which you can use right here. Wood on wood, and this is not static friction, this is sliding friction. The coefficient of kinetic friction is 0.2. So you have to look this up, 0.2, and that's from the table in your textbook. And that table's on page 131. Well, now we need, so we got this, now we need the normal force. Well, we do that by looking in the y direction. And so we say, well, what are the forces in the y direction? Well, we have the normal force minus the weight, right? The normal force is in the positive y direction. The weight is in the negative y direction. And those are the only two forces acting in the y direction, so we're finished with that. Now, what is the acceleration in the y direction? It's 0. This problem is, there's no acceleration in this problem at all. So this just tells us that the normal force is equal to the weight. Now, I tell you what, this is a little overly, I'm being overly methodical. If you just were given this problem and you say, oh, okay, the normal force is just equal to the weight, I'd probably be okay with that. So now I can solve my problem. Now I go to step 5, which is just, well, actually I've been doing step 5. This is step 4 right here, getting these two equations. And then step 5 is just solving for your unknown. And now you have to know that friction equals mu times the normal force. So that's going to be 0.2. And you can put newtons per newton if you want. But then the normal force is just mass times m times g. Well, the mass is 25 kilograms. And g is 9.8 newtons per kilogram. Yes, you can put meters per second squared if you want, but think of it, there's no acceleration here. It's not in free fall. So this is really the strength of gravity. Gravity on the Earth pulls with 9.8 newtons of force per kilogram of mass, so that the kilograms cancel. I'm going to get newtons. And when you multiply all that out, 0.2 times 25 times 9.8, you get 49. And that's the answer to our problem. And again, I want to emphasize using the procedure and not trying to take a lot of shortcuts. These problems are not going to be fast. They're not going to be quick little problems. So don't try to turn it into a quick little problem. Go through the procedure very carefully. If you do, you will get to the right answer and it will save you time. If you try to take a lot of shortcuts, you're going to get the wrong answer. You're going to have to go back and fix it, and it's just going to be a drag. So just be thorough. That's all.